All right, thank you for joining us for this edition of one-step equations. Okay, so what do we have when we have one-step equations? Well, it means we only have to add, subtract, multiply, or divide. We're taking one simple step to solve. So we're going to start with some adding and subtracting one step, and then we're going to combine this video with the multiplying and dividing. I know in class that we separated it, but in the video, we're just going to make one video titled one-step equations. So here we go. When I'm talking about equations, remember we're talking about a balance beam. We can say that this word is equal, or this symbol here stands for equal. 21 plus r is equal to negative 63. Or we can look at it as being the same as. This equal sign really means the same as. And when we think about it as being the same as, oops, hold on, it's not letting me type. The same as, then we can think about this as some sort of a balance scale. And maybe you know the kind of balance scale I'm talking about. We have the arms that will go out here, and if I put things on my scale, it already looks like this side's heavier because it looks like it's not balanced here. Let's see if I can even that out a little bit. But when we have these balance scales, we'll put items on here. If I put a 3 here, to keep it balanced, I have to put a 3 here. If I put a 13 here, to keep this balanced, I have to put a 13 there. If I took away a 3 and it left me with a 10, well then to keep it balanced, I have to take away a 3 from this side because I want the left side to be the same as the right side. So let's think about that here. I'm going to separate this through the equal sign here. I'm going to draw what we call the train tracks, or really it's just that point of where the fulcrum would be, where that balance point would be for the two equations. I know that I want this side, 21 plus r, to be the same as this side, negative 63. There are a few conclusions that I can make about the variable r. I know that my answer is negative, so I know that r must be negative because I'm adding something to it and I still get a negative answer. So I know r must be negative. I know that r cannot be positive because if they were two positives, well then this answer would have to be a positive. So that gives me a little bit of an insight when I'm solving my problems. I know I want r to be the only thing on my scale, and sometimes I imagine this little scale here. I'll redraw it, but I imagine that little scale as I'm doing my work. And as I balance, I see a 21 plus an r on this side. And I see a negative 63 over here. Well, you know what? I want to take this negative 21r off. I'm going to subtract that out. I'm going to take that away. So I'm going to, down here, take away 21. But now this whole scale here is not going to match unless I take away 21 from this side as well. So I need to take away 21 from this side. So I imagine in my mind this is what's going on in my scale. The 21s are going to cancel out because I took them out. I have this r left over, which is just what I wanted. And now I have this problem. I've gotten used to looking at my math problems vertically like this so I can see. But for some of you, that's a little bit difficult to see what's going on. So what you might want to do is vision this off to the side as negative 63 minus 21. Because if you visualize it horizontally like this, you're more likely to notice the fact that you want to do additive inverse. And now I notice that I have 63 negatives and 21 negatives. Well, a bunch of negatives here plus a bunch of negatives there are going to give me a negative answer. 63 and 21 make a total of 84. I'm going to box that answer. And then the beauty of one-step equations is that I can check to make sure that I'm doing it correctly. So I'm going to come over here and I'm going to perform the check. I know that I want 21r to be the same as negative 63. I know that I just solved r to be negative 84. So I'm going to have a 21 plus, but instead of r, I'm going to put in that negative 84 because that's what I just solved it to be. And I want that to equal negative 63. So I need to think and do some mathematics. I know positive 21, negative 84, that the negatives are going to win. And then I just subtract the 21, and I might even do that work further off to the side here. I wish I could scroll my screen over, but it doesn't. So I'll just take a 84 minus a 21. 4 minus 1 is 3. 8 minus 2 is 6. I already knew my answer was going to be negative because there were more negatives. So 63 negatives equals 63 negatives. Does that check? Sure does. So I know that's my answer. Most of these problems are fairly simple. There's no real challenge other than knowing what to do first. So I see this, and now I'm just going to pretend, because that's what variables are. I'm going to pretend there was a number here. And if this said 10 minus negative 12, well, what would be the first thing I would do? I would do the additive inverse and then solve. So if that's what I would do with a number, that's probably what I should do with a variable. So I'm still going to do my additive inverse. I also need my railroad tracks, my barriers, to show me what the balance is. And now I'm going to look at these problems. I have m plus a positive 12. So on my balance scale, and I'm not going to draw these for every single one, but here's my balance scale again. I have 144 over here, and I have m plus a 12 over here on my scale. Well, m plus a 12 on my scale. I want to take 12 away from here, so I'm going to subtract 12 from here. But again, that's going to cause my scale to not be balanced, so I need to make sure to take away 12 from this side as well. That means these go away, and I'm left with m equals 132. Again, the beauty of this mathematics is that I can go back and I can just double check using my check. So I had m minus a negative 12 equals 144. I know that m, we just solved it to be 132. So now I have 132 minus negative 12 equals 144. Minus a negative is like adding the opposite. And now I have 132 plus 10 is 142, plus another 2 is 144. 144 does equal 144, so this checks out. I'm going to give you two problems here. I'd like you to pause it and come back and see what you get. Welcome back. Hopefully the first thing you did was set up your scales so you know what two sides you're talking about. So it's the same as side 1 and side 2. I know that I want to solve for p. I want to get p all by itself. So in order to do that, I need to subtract a 9 because that's a positive 9. So I have to do it to both sides in order to keep my scales balanced. Those are going to cancel each other out. And now again, if I were to write this horizontally, I would do additive inverse and find out that I have a negative 16. I'll go back and I'll do my check just to make sure, because that's an easy way to get an A on the test. P plus 9 equals negative 7. P stands for negative 16. Negative 16 plus 9 equals negative 7. Negative 7 equals negative 7. I checked out. I'm good to go. All right, so for the last one, I had to subtract 16 from both sides to keep my scales even. P equals 41. I'll go back and do the check. Make sure everything is working out okay. So now I have 41 plus 16 equals 57. And all this is doing is adding, so that's easy enough for me. 4 and 40 and 10 make 50. 1 and 6 make 7. Does 57 equal 57? It sure does. It checks. But like I said, we don't only have adding and subtracting, we also have multiplying and dividing. So it's still similar. I still want these to balance out. So I'm still going to have the balance scales for them. The only difference here, the only difference here is I can't just simply add and subtract. I have to think a little bit deeper about my balance scale. So I'll draw a balance scale here again. And I want to have 3 triangles right here. 3 triangles. And I'm going to tell you that those 3 triangles equals 15 whatever over here. So I need to figure some stuff out. So what I'm going to do is I'm going to say, well, you know what? If I have 3 triangles, and I'll draw it that way just for my image, and I have 15 somethings. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we'll dab that out of here. 8, 9, 10, 11, 12, 13, 14, 15. Well, when I do it this way, I notice that when I, divide it into 3 groups, that one triangle is equivalent to, or the same as, 5 units of whatever the other unit is. So what did I do? This was like having 3 triangles equals 15. I divided it into groups of 3. And when I did that, I found out that a triangle equaled 5. So how do I apply that to this problem that we have in front of us? Same way. In this case, I have 21 triangles, or 21R. I'm not drawing 21 triangles. But all I know is that if these are multiplying, the opposite is to divide. So I'm going to divide both sides by 21. 21 goes into 63, 21, 42, 63. 3 times, and a positive and a negative is a negative. How do I check my work in this case? Well, I'm going to check it the same way. 21 times R is negative 3, equals negative 63. 21 times R is 63. Positive times a negative is a negative. Does negative 63 equal negative 63? Sure does. It checks out. You try the next 2 problems, and we'll see how you do. All right, welcome back. Let's see how you did on these 2 problems. Hopefully you paused it. If not, quickly pause it, then come back. The first thing I'm going to do is draw my equal to signs here, the same as my balance scale. I know that I have 12 m's. I notice they're negative, but I'm going to focus on the fact that I have 12 m's and they're multiplying. So the inverse I divide, and I'm going to bring the negative sign with me because that whole thing right here is bothering the m. So I need to divide by that whole thing. Whatever I do to one side, I do to the other. M equals positive divided by negative is a negative. 144 divided by 12 is 12. And I'm not sure where that dot came from, so we'll just make a 12 like that. All right, come back and do my check. Negative 12 times negative 12 equals 144. 12 times 12 is 144. Negative times a negative is a positive. So yes, that checks out. And last but not least, if I was to draw my balance bars here, I notice that I have a P. The P is being multiplied by a negative 9. So the inverse or the opposite is to divide by a negative 9. So I'm left over with a P. Negative divided by negative is a positive. 72 divided by 9 is 8. And then I'll go back and do my check just to make sure I'm okay. Here's my check. I have negative 9P equals negative 72. And instead of a P, I have an 8. So negative 9 times 8 equals negative 72. Negative times a positive is a negative. 8 times 7 is 9 times 8, is 72. And negative 72 equals negative 72. So I know I did that problem correctly. So you might be asking yourself, we have one more thing that we haven't talked about yet. It's dividing. But the same factors still remain. I still have a balance, and I want to balance each side. I'm going to give you a chance to try this first. All right, hopefully you paused it and you came back. Let's see if you were able to guess. So in this case, I'm solving for the d, but it's being divided in half. And I don't want half of a d, I want the whole d. So I need to multiply it by 2. Whatever I do to one side, I have to do to the other. So now all that remains is a d equals 36 times 36 is 72. Positive times a negative is a negative. I'm not sure why that keeps connecting like that. But negative 72 would be my answer. It's very simple to go back and check. All I need to do is go off to the side and perform my check. So I have a check. We'll see, here we go. So now I have negative 72 divided by 2 equals negative 36. A negative divided by a positive is a negative. Half of 72 is 36. Does negative 36 equal negative 36? Sure does. All right, hit pause. Try these two. Come back. Let's see what you get. Hopefully here for this first one, you were able to get that d equals 36. And here, d equals negative 15. The work that goes in behind it, in case you weren't sure, remember, you want to draw your balance beam, your railroad tracks, to separate the two. I want to multiply this by negative 9 and multiply this by negative 9 to undo this operation, do the inverse. So d equals negative times a negative is a positive. 4 times 9 is 36. Go back and do your check. D over negative 9 equals negative 4. D over negative 9 equals negative 4. Sorry, that's just a random one that came around here. I know that d is 36, so now I have 36 over negative 9 equals negative 4. Positive divided by a negative is a negative. 36 divided by 9 is 4. And negative 4 equals negative 4, so it checked out. Again, here's my balance beams. I want to solve for d. It's being divided by a negative 3, so the opposite is to multiply by a negative 3. D equals negative 15. If I was to come back and show my check, I would have d over negative 3 equals 5. I know my d is a negative 15, so negative 15 over negative 3 equals 5. Negative divided by negative is a positive. 15 divided by 3 is 5. And yes, 5 equals 5, so that checks out. Hopefully this was a little bit of help for you if you were struggling with your one-step equations. And I look forward to our next meeting with two-step equations and writing equations.